Yeah, hello. What is, am I audible?
Yes, sir.
Okay, thanks. Okay, so yesterday, uh, yesterday what we did is we looked into imputer, uh, then we looked into encoders, and then like scalars. So imputers are there is one which is simple imputer. Another is there like KNN is there, KNN imputer, but uh, we will cover it when we'll cover KNN part, like K nearest neighbor, right? So that algorithm you might have known, but to explain the code, a little bit of KNN code will also come. So I think it will be along with the KNN algorithm. Okay, so it's just that like for the information purpose, and then in encoders we have uh, one one hot encoder, and there is one ordinal encoder. So so this all are like these two are related to feature only. Okay, these are like feature encoders. There is something called label encoders also. So I mean feature and label is X and Y, right? So there is one thing called label encoder, which does same as ordinal encoder, same thing. Like there is nothing difference in that. But we use label encoder when we have Y thing, because what will happen is the class, the label encoder class will be written like that it will accept 1D array. Like otherwise, you have seen that in ordinal and one hot encoder, it wasn't accepting 1D vectors. It required 2D array, data frame or something like that, right? So it wasn't working like that. Uh, so that's why it is this different encoder was built, but it is the implementation was same as ordinal encoder. Whatever labels are there, it will just convert it to 0, 1, 2, 3 like that, right? So if it's like that, then there are like four classes uh, are there in the labels. Yeah, and there is scalars. So in scalars, we covered like standard scalar, standard. Then we have mean max scalar, mean max. Then there was max absolute, okay, max absolute scalar. This three we covered. Uh, so standard scalar looks like Z score. Mean max scalar is something we wanted to convert numbers from 0 to 1 range, and in max absolute if we wanted to convert them in range of -1 to 1. So the range will be limited, right? So we do scaling so that all of the features uh, are in same scale. Otherwise what happens is, so let's say we have this a 3D, let's say 3D or something, right? Let's say one axis is in thousands, like the values are in thousands, like it is like very far in one dimension. Then in another it's very small, like let's say 0 to 1 only value. So like let's say this is the part in which this exists, like all the points, right? And like in X, okay, around 100 or something. So what will happen is when you do gradient descent, uh, you do gradient descent or not, right? So this loss function will be there. So uh, there is like mean squared error, or it's like for regression and all, right? And uh, for logistic and all, we use cross entropy. No, cross entropy is a multi that. For this, we use binary, which is like log of uh, log p into log p, something like that. Okay. Yeah, so something like this. So we use loss function and all. We want to do gradient descent, and in gradient descent, this all the features of same scale will come into picture. So this gradient is there, right? So you go down like this. If all the scales are not in same, all the features are not same scale, then you might not able to come to the minima, right? The global minima. You might stuck at somewhere here or something like that. It's possible. So we do this. Okay. Now we see code wise also how to implement that. But there is one like, so the problem now is that we have this all different encoders, features, imputers, and all you did on train set, and you want to do same thing, exactly same thing on test set, like the process wise, right? So let's say I do impute on thing, then I go and encode things, right? And then I go and do scaling, right? So scale them. So this is a process or workflow, like the flow
Sir,
of the.
may I ask a question?
Sorry,
I have a question.
yeah, tell me.
Sir, all these things, the changes that we are making to the data, like impute kara, फिर coding kara, all these will be reflected to the real data?
Yes,
Okay.
yes, we have to do it, right? I mean,
नहीं मतलब
data,
जो
real
भी हम
data.
चेंजेस करेंगे ये सब जितना भी होगा इम्प्यूट करा एनकोड करा या जितने भी पाइपलाइन के थ्रू हम जो भी स्टेजेस करेंगे उन सब
uh,
में जितने भी चेंजेस आएंगे वो रियल डेटा को रिफ्लेक्ट करेंगे क्या रियल डेटा में भी चेंजेस आएंगे क्या
चेंजेस, यस, हाँ, चेंजेस आएंगे, बट वो चेंजेस, सो अभी चेंजेस, लेट्स से एनकोडर, इट्स अ स्ट्रिंग वैल्यू, राइट? सो इन स्ट्रिंग वैल्यूज को नंबर्स में रिप्रेजेंट करने के लिए
हाँ
हम
वी
एनकोड
विल
करते हैं,
एनकोड हाँ
राइट?
एनकोड करते हैं
No,
वी
but
सो
will this affect the original data set
हाँ
is what she is asking, sir.
so it will not affect the data set unless it's imputation. In imputation it will affect,
ओके
um, because we are doing something which was not there at all, like it wasn't existing. What we are doing is we are putting something mean median mode, I mean, as best of our assumption, on best of
means
our
Based
other
on the
assumption.
other
values.
other than impute all other changes will not be reflected it will not make any change to the data set
Yeah, it will not
okay
impact the data set. Yes, it
okay
will be as it was, like we can recover
only
the.
till the time we are running the program
Yes,
it will be reflected for the model training उसके अलावा the data will not change yeah? Yes sir
while modern, like, I mean, okay, let's change. If it does change, then what's gonna happen? I mean, then what is the.
So then the categorical
like
variables like male, female, and all will change to numbers, no?
binary
Yes,
हाँ, numbers
So then
the
one
real
more
data
encoding
also
kare to we get three columns, more, four columns
more
extra. That's
yes,
what she's asking, whether it will affect the data set. Suppose we take that housing California data set and we
okay,
do all these things step by step. Impute, I understand because the null values will be replaced, but encoding, scaling, and all, will it change the original data set also? तो ये categories and all will be changed to numbers and
yes,
not encoding करे तो so
yes,
it will affect the original data set.
uh, yes. I mean, not in a way like statistically speaking, no, but look wise, like it will look different, but statistically it's the same thing. It's just we are representing it with numbers.
Right, sir. But when we do generally when we do in place is equal to true, it affects the original data set also, right?
Yes,
Usually,
I mean, it is gonna change.
likewise.
Yeah, yeah. That's what we
Okay, it will
wanted to do,
change.
right?
Yeah,
We
okay.
wanted to change it.
hmm.
I
Hmm.
mean,
okay
yes, to
So the
make the changes.
next time, suppose after the session is done, next time I'm again importing the housing California. That will be a changed data set.
No, I
No,
mean,
that why that would be the
only
case?
On
only in that
only
session you pull it, that
That's
would be
what I
changed.
wanted to
on
ask
that
you.
If
It
the
is
only.
not
runtime is deleted,
permanently affecting the data set.
no, it's
Only
not
So
actually.
let's see. Okay, wait. I'll explain. See, data set is coming from a database, right? Some database. In our case, there is no database. We have CSV file. Okay, this is the CSV file. Now you whatever changes you are making to a data frame. Okay, the data frame is there. You created a data frame out of that, which is another variable. So you can say this is a variable, Python variable or something like that. You can consider it. Okay, so now this variable we have in which the CSV data is being stored, and we are making changes on data frame only. Okay, all the changes. Now, do you want to store it in a different file of CSV, or do you want to altogether change this CSV at all? Like you can do that, right? This is just a file. You want to make changes permanently or not? That's your choice. I mean, uh, CSV file is not going to change, right? Since it's just a we are not making any changes in CSV. We are just making changes on the data frame. You want to make it reflected back to the CSV. That's your choice. You can do it. Uh, but
no,
generally we
my
don't do it.
question is only, I'm only asking related to data frame. Data frame will change. You said yes,
Yes,
it will change. Yes,
yes,
that
yes.
is my answer.
That's that is our task.
That,
That's what we
yeah,
wanted to do. That's why
yes.
we
Okay,
are
sir.
doing all this now. Right? Okay.
Okay, thank
So
you.
yeah. So
Sir, how to change the CSV file? You said if you want to change CSV file altogether, then how to do that?
how to do that? So what you can do is like uh, like writing CSV. Like how do you write CSV? Like you write in this format, right? Then again you write it again. Like whenever you can open it again and write it. So CSV writing, that's what we are doing. You can change it that way, but you want if you want the function, then there is like you can write df dot to CSV, I guess to CSV or something like that function is there. You can give the file path. So file path you have to give, and of course it has to be connected, right? If it's in your drive, then like that, and you also should have permission also. Like let's say you are changing a file and you don't have permission for that. You only have reading permission, then you can't change it, right? So you can only change your own files or something like that, right? So file path give it, and so to CSV you will do, then the file will change function wise.
Okay, sir.
Excuse me, sir.
Yes.
Sir, I was solving practice assignment of week 3, and
Yes.
I pasted the data in Google Sheet, and I replaced the question mark values with the mod. And sir, may I share my screen?
Sure.
All right, sir. Thank you. Uh, Sir, is my screen visible?
Yes.
Just a second, sir. Just a second, sir. Just a moment. So I applied this after replacing all the question mark values with the mod. I
Hmm.
applied this formula. So what it is doing is it is subtracting this value with the minimum value of this row, which is actually 0,
Yes.
and the value I should be receiving is 2. but instead I'm receiving 0 as the value. And it's a weird kind of a 0.
So you wrote A2 minus minimum. So A2 is 0. I can see A2 is 0. And from that you're minusing 0.
Oh, this is the same, so.
Yeah, I mean from 0 you're subtracting 0, right?
Oh, I'm sorry, sir. I'm sorry. Actually, I pasted this formula from another sheet, and that is why. I'm sorry, sir. I have one more doubt.
Okay.
Sir, let me uh, stop presenting my screen. Sir, there is a parameter called return underscore capital X underscore Y is equal to true, right? For getting the separate values for features and label, right? So
Sorry, come.
for some data sets of sklearn dataset library, we have
Okay.
a function called not even function, a parameter called return underscore capital X underscore Y is equal to true, right? When we
Yes.
fetch the data.
Yes.
So
Okay.
this parameter is not valid for all the data sets in the sklearn. Is it true?
Mm, it might be true. I'm not sure. Like, if it is valid for all of them or not. I mean, depends on.
Uh,
I don't know from where you're importing. So there is one OpenML thing is there. I think if you are importing from that, then it might doesn't work for some. I'm not sure though.
Sir, why is it that because this parameter works for California housing price dataset,
Mm, okay.
but it doesn't work for other datasets like breast cancer or iris. So, what's the reason
For
behind it?
Iris
That
it works,
why?
right? For Iris it works. I am sure.
Maybe then it's diabetes, or maybe it's
Yeah, so
breast
depends.
cancer.
No, see, whoever defined, see this API is there behind that where from. So this is a function, right? So the working of function depends on what is written in the backend also, like how they are giving it to it. So whoever from wherever it is, extracting the data, that doesn't have that feature, or that way it was not written there. So that's why we are getting this error, right? So like you write a Python function, and you have assumed that in this way data should come and all, but let's say it doesn't come like that, then it will not work. Okay? You will see errors. So that's how it is. It's just a function.
So, so the bunch data needs to be arranged in a particular manner for this function to work, right? The bunch
Yes.
object.
Yes, like yes, something has to be done from. I'm not sure what kind of uh, error leads to this, but there would be something they have missed it, and that's why it's not working. I mean, whoever created, like let's say the creator is different from the sklearn people, right? This people are different developers. Who created sklearn, this whole thing, classes and all is a different one. Whoever is working in OpenML is a different person. So they might never even contact with each other. So I mean, it is
So,
like that.
all right, sir. So, are we also are the solutions for the practice assignment going to be discussed in any of the classes?
Uh, so generally we leave it to students, but if you have doubts, we cover it in anywhere. Like in sessions, we do
Sir,
cover it.
actually, the supplementary contents don't have the practice assignment solutions.
Uh,
They only have the lecture slides and the lecture transcripts.
yeah, correct. So since practice
Why
assignment
is it
solution will
not
be,
uploaded practical assignment solutions?
it is along with graded assignment solution. That's why. I mean,
And graded
uh,
also, see, week 2 is already done, but none of the graded assignments are uploaded there. So till graded week 2, it should be uploaded, right?
Yes.
Sir,
Yes,
I
yes.
have sir, I have just completed a practice assignment of week 3, and some of my answers are incorrect. So, would you mind having a look at my codes and discussing the answers today?
Week 2,
It's just week 3.
week 3. Graded
Yes, sir.
assignment.
No, so practice assignment.
Sure, sure,
Okay,
we'll
so
do that. But
at the end,
yeah, at the end would be better. Okay, let's just
all right, sir.
go through and so we'll cover pipeline and column transfer, then we can go through it.
All right, sir. All right, sir. Thank you, sir.
Okay, so yeah, I was saying that we had this all thing, right? Now see this thing we did, like first we imputed the data frame with our strategies like most frequent, uh, most frequent, right, and mean, then there is going to be median and constant, something like that. So different column will require different kind of handling, right? So and this then after I do this, then I'll do encoding also. Then encoding also will require something, uh, something like, let's say if it's a nominal, then I'll do one hot encoding. If it's a ordinal, then I'll use ordinal encoding, right? So same thing, like uh, yeah, and in scaling, mostly it doesn't matter, like you can do both, like anything, like any three, any of the three you can use, standard scalar, this mean max scalar and max absolute scalar, anything you can do. So the now here we have this something like conditions and all. Now earlier we did all the things manually, uh, like each case by case for training set and test set. I mean that's good, for understanding purpose it's good, but ultimately what we want to do, we wanted to create a streamline or a process flow or something like that, right? So something like, a data goes inside any data, like x train, x test, uh, x validation, right? All this thing are there, and let's say in later on in future, let's say there is like incremental learning, something like that, that will come, right? So incremental learning is whenever we have data availability, we retrain the model, then we wait for some period of time, let the data to come to us, like gather data and then retrain the model. So model retraining happens, uh, I mean, periodically, monthly, weekly, depends on data. So like this whole thing will come later on, like not in perspective of course, like we'll always use CSVs and all, but in reality it does happen. So we need to create some process, and then we'll have clean data, right? So this cleaned data and all, and every thing should have similar format, right? So the X train, let's say, have uh, 15 columns, and the order of it, like order or orient order, right? So whatever is first should always be first for all the things. Like let's say X test went in, like in this flow chart, in this pipeline or something, like and we should have same order for X test also. uh, Similar thing like X test and X validation rows. So they all should have similarity wise, like columns, number of columns, and order of them, the columns also. Otherwise, model will not do that testing, like validation, prediction. You can't make it otherwise. So that's why we need something to do that, and sklearn provides two things for that. One is column transformer, and another is pipeline. Okay, so they both come from different uh, like module or something, right? So pipeline comes from pipeline only, like that is called sklearn dot pipeline, and column transformer comes from compose or something like that. Compose. So from that is column transformer, right? And this pipeline is same name. Like again, you have to write pipeline, same thing. So now let me explain what we are going to do is, like, let's say I have 4 columns. Okay, column 1, column 2, column 3, and column 4. Okay, and let's say what kind of any kind of data I have, doesn't matter. What I want to do is I want to impute here, let's say mean. Here I want to impute most frequent, and here let's say I want to do median, and I don't want to do anything, like nothing in column 4. It's just all okay there. Okay, so since I have 4 different columns, what I have to do is I have to create this simple imputer. That is true. I have to do that. So simple imputer, and will contain some strategy. That this 3 strategies will be there one by one. So I will create that, like SI1, simple imputer 2, simple imputer 3, like same thing. Everything is same. Just strategy is here. Let's say here is mean, and here it could be most frequent. Okay, and in this case it's median or something like that. So I'll just
Sir,
change the strategies. Yes.
sir, I have a doubt. See, we are dividing the entire data set into train and test, right?
Okay.
So now, if you're see, these imputers are all for the null values. We are replacing it with respective mean, most frequent, and median, and all. Suppose in the train data set in column 4 there are no null values, so you have not done anything. But in the test data set you have null values. Then how does this imputer work there? We should do the same thing as the training in the test, right?
Uh, so
Because we are
let's say
dividing the entire data set into one portion as train and the other portion as test. So some
yes.
of the so 80-20 means 80% of the rows will be going to the test set, and 20% of the rows will go to the 80% will go to the train set, and 20% will come to the test set. Say, let's say suppose that 80% data, in that 80% data, column 4 doesn't have null values, but in the 20%, if column 4 has null values, but in the train set we have not done the simple imputer in that column, then how about in the test set?
So in that case, what you can do is, uh, I mean, you remove that rows and then predict whatever you have. Okay, so you do that because you are doing prediction only. Training has been done on the,
Hmm.
like, training is done. But let's say if this test set like this, regularly new data is coming up like that only, like column 4 is having null values, then while retraining the model you can do that. You uh,
So if
you
we, while
add
retraining the model, we can do the simple imputer in the train set. So none of
yes,
the values will be replaced, but the same can be applied in the test set, wherein if the null values are there, it will be replaced, right?
yes. So while retraining you can do it. So let's say first time you trained it, you get to know that there is a null value present in test sets and all. Now, I mean, I didn't do anything about that. So you have to retrain your model then.
Okay.
I mean, retrain the,
Retrain means we have to include the column
yes,
4 also in the simple imputing thing.
yes, and then retrain.
Okay. Thanks.
Okay, so I created this all these different imputers, and so in column transformer, what you can do is, so I had different transformer, right? So in that, what I have to do is I have to mention strategy or this thing, right? So let's say I'll call it SI1 or something. So I have to call SI1 say okay, SI1, and then I have to mention column name or column index will also work. Okay, so column name I have to give. Same thing I have to give SI2 and then column name and SI3 and then column name. So I have to do it like this, and there is another option in column transformer which is like remainder. This is a parameter in that. Okay, remainder. So what we'll do is we'll keep it as remainder. So there is one is drop. Drop means it will drop the remaining columns. Whatever column is not mentioned in this thing will be dropped. But we don't want that. So there is another called pass through or something. I mean this thing you have to read like why drop is there and what values does other than this exist or something like that. You have to go through the documentation of this, right? So I'm really teaching documentation or something, um, but uh, that's how we it's in this course. So the column transform is there. Then we mention all this thing. Then we can mention this thing. So that's how we cover all of them. Okay. Now what will happen is uh, it will happen like this. Like let's say the column 1 was there, uh, column 2, column 3, column 4. It will do different kind of imputation and then merge it up all together, and I'll have again data frame. So I had data frame here. uh, it was it went like this, and I have like this, right? So like this. Okay, so something like this. So now you have this picture like this, you can say. It's coming from the data frame and then again merging up as a data frame. I mean, it all went to different streams. So this is stream 1, you can say stream 2, stream 3, and stream 4. It went like that, and then again it's merging up, right? So if you want to do it, you have to use column transformer.
So what activity is happening in this different streams, sir?
This activities, imputation. Imputation is
Okay.
happening in.
Okay. Okay.
Okay. Then so this is something we do when we wanted to split the columns. So like different columns on different columns, we want to do different things, right? That's when we'll use column transformer. So you have to think it, right, that you want to do it different, or no, you don't want to do different like in different columns different things. Otherwise not needed column transformer. Okay. But of course we'll need it somewhere. Then let's say I did encoding. I mean I did all this thing imputation. Now what I want to do, I want to do encoding. Then encoding also same thing. I have this data frame again. I want to do either it's a nominal or it's a ordinal, right? Then if it's nominal, I will do one hot encoding. If it's ordinal, I will do ordinal encoding. I'll use column transformer again and then create this, right? Then on all of this thing, like this all the things, again I'll have the data frame, same thing. It might be different data set. Okay, I mean like I'm not saying this df is going to be same as this. It's updating inside. New columns are getting added because of this maybe. Okay, and the values are getting removed. So the columns which earlier had uh, string values and all will get removed automatically from this, and it will have numbers now. So something like this, all changes are happening. Now I have data frame, and on the data frame I want to do scaling only, like one thing, scaling. So if you see this whole picture, this thing, uh, this whole thing is a pipeline. Like from one like this was imputing, then we did encoding, then we did scaling, right? So this is a pipeline as this. Now we'll see how to write the code of this, but you got the idea what is like what it is.
Basically, something like a flow chart,
Yes.
wherein the actions are being put inside a pipe and being executed
Yes.
in order. Correct?
Yes. Okay. Okay, let's write code for this now. Like so, we I will okay. So yesterday we did all of the things in this one only. I'll do I'll use that same thing. Okay, so I already imported data and all. Uh, Everything is there, like same data frame. I'm using the one which was like this, right? Uh, Housing price. You have to predict the sell price of the house, and we did all the encoding, scaling part uh, with the separate module and all. But now we wanted to streamline it, so we'll use column transform and pipeline. So so first let's do the first one. Like let's say for from sklearn dot column sorry compose. Yeah, compose. Then from compose I have to import column transformer. Okay, so I'll do that. CT. So CT is just the name I'm using for the object of column transformer. And so generally, in column transform, there are parameters like this remainder is there, right? Like I mentioned, you can give like you want to pass through or drop the rest of them. And others are like sparse as well, okay? Transformer weights. So the important one is like this transformers, like I mean inside what transformers you want to do. So this all were transformers like which we used encoders, scalars, imputers. They all are transformers, okay, in sklearn term. So we can give all of them here. So to give them, like I said, we let's say call it as TF, the transformers. So this transformer is going to be a array. This array will carry tuples, okay, like this tuples it will carry. So inside one tuple, we need to give our transformer thing. Like let's say I said SI1, then I have to give the column name, right? So let's say column name was I can see this part. So let's say imputation I was doing on estimated value or yeah. So let's say I wanted to on locality or something. So I'll mention locality. Uh, but what's there is no issue with it. But sometime what happens is you will have NumPy data, not a pandas data frame, right? So when that is going to be the case, you can give index of that. So index of locality is 0, 1, and 2, right? So I can give directly the index of that. It will also work. if it's a NumPy array. I mean, in pandas also it will work. Doesn't matter. But this there is few thing in this which is like important. Is this naming will be a array. So I mean, see now the problem is it contains a array. Array inside array there should be a tuple. And in tuple there are three things you have to write. So like this you can write like one thing, two thing, and the three one, right? Third one. So three things you have to write. The third one is going to be a array. Again, like array, and array is the columns on which you want to apply this transformation. So let's say you wanted to do uh, most frequent thing, and you want to do most frequent thing on two columns, three columns. This imputation most frequent thing, right? So you can mention all the columns name here, like locality was there. Say locality was there, and what what else is there? Let's say property. On property you want to do, but with property the problem is it doesn't have null value. It has question mark. So either you remove null value or question mark with null value and then put it here. That will work. Okay, that you can do it. Like replace all the question mark with a null value, and you can use it. And here we need to give the simple imputer thing. So simple imputer is like this. Simple imputer. I'll mention strategy is equal to most frequent. And then the first one is it's like kind of necessary. We just give to name it something. Like let's say this process is something. So to naming, it's your choice. You want to give any name, you can give it. So maybe like it's a mod impute or something. You can give any name. So A B C D anything will do. But this has this is our this class, right, of simple imputer class I imported, and these are the columns. These are like you can't do anything here. Like uh, you have to keep the names as it is, or you have to choose the column index as it is, like 2 3 or something like that. Here you can write anything. So this is how the thing is that you have to keep it as a tuple. So this is a tuple, first tuple. Okay, my first tuple is this. See, it starts yeah, this is the first tuple. Then the next tuple will be same thing. So three things I have to write inside this. Like let's say I'm doing median impute. I'll use simple imputer, and I'll use strategy is equal to median, and then I'll use the column name. So column name is, let's say, estimated values there. So just estimated value. Okay. So this is how I can put it as. Yeah, something like this. So this is my second tuple. Then let's say my third tuple is uh, carpet area. So for carpet area, yesterday we use mean. So let's say I'll call this as mean impute, and same thing. See, so this is how the whole array is being written. Okay, so this whole array I can call that as a TF. TF is a variable. I use it for, and I have to give it here. So I mean, you can directly write this inside this rounded bracket. That is also not a problem, but I do like write it separately and then give inside it, just a readability purpose. So so if I show you the how my I mean, TF will look like this only. So how my CT looks like. Currently, currently there is like remainder. So by default, remainder is equal to drop by default. Okay. So if I do that, then you won't have this thing anything else than this, right? So the remainder, like all the rest of the columns will get dropped. So in the end, you will have four columns only, 1, 2, 3, and 4. Okay. The rest of the columns will be removed. And so, and this is the thing, right? Like we saw in our diagram that you will have this three, and then they are coming together at one place. And if I keep remainder as pass through, then we'll have uh, one more of this thing, which will contain all the rest of the column. So this is the remainder, all the column. And let's say if I do this CT dot, fit and transform, let's say I do it on DF. So later on we'll do it on X train only, right? Uh, Currently also we can do it, but I have to make X train. Yeah. Here we have X and Y. See, strain has question mark, has null values. Okay, so it has null values and all. Okay. So we will do that same thing on X train. X train, I'm doing fit and transform on X train, of course. If I do that, I'll have my output as like this. So there's one thing we can do is we can make it as pandas. Okay. So, so since I mentioned like in question marks, we can replace it with the null value. So if I do that, like let's say X train dot replace question mark with like np.nan, and I can do that. Yeah, for X test also I could do. Correct. So I can choose column also, like which column it has it, like property as that. For residential, that's the property. If I do that, and it is not different. That's okay. What I can do is pd dot and same thing, just the null value. In pandas, it's like this. So now I can do it. And is ambiguous. Boolean value of something is an So select to run explain. Let's write this. Something like this. So I imputed question mark with null, and now I can do it on property. And say I have imputed mod impute from locality. So the column names will be like that. So you will know that from where it came out. Like so this is from mod impute thing. This is from median impute thing. This is from mean impute, and this all column came for remainder. This one, right? Remainder part. If you wanted to close it off, like you don't want that, you can maybe write verbose. So now it looks like this, like property, locality properties, like it was earlier, right? The initial. But there is one case that the columns have changed. You see the df uh, or x in Matplotlib, like so the columns have changed a bit, right? So from x we made x10 and x. Yes, so you see x, it has like date first, year, then locality or something like that. But now it changed to locality property and all because of this pipeline. Like first, whatever is there, it will get concatenate with the second one, then the third one, then the fourth one. Remainder is all remainder is always going to be the last one. We can't do anything with that. So whatever transformation we do, will all the columns will come in front. Okay. So this is the first transformation we have made in our columns, which is imputation. Now I want to do nominal and ordinal encoding on few columns. So again, I'll do this, create this column transformer and all right. So let me call it as CT2 column transformer. I need to give transformer two. So okay, so I need to create another array of tuples. Create that array of tuples. So say this is a tuple and something like that. First one is name. So let's I'll do nominal encoding, or for one hot encoding, you can call it. So that will contain three parts, right? So here I'll create one hot encoder. I don't want sparse output, otherwise, pandas will not be able to read it. So that's why I'll keep it as false. And then the column names. So column names will be locality and face. And it's like we did earlier. Then we want another one, which is ordinal one. And we will use that only in file. So in ordinal encode, we need to mention the the categories, that part we have to do it. We'll do that. And the column name, right? So column name is property, property, and residential. Since those two are ordinal columns and locality and place are nominal columns. So on nominal, I'm using one hot encoding. Okay. Now I the another thing is like there was one like drop is equal to first also we can do. Okay. So it will drop one column from each new created one. Okay. In ordinal, we need to define the categories. So I'll just take it from yesterday's one, whatever categories we defined there. This one, like this whole thing. Yeah. Something like this. So see either I gave this ordinal encoder or I have created a object of that. So I can give this one also. Same. I don't need to put bracket or anything because uh, it's, it should be put it in here. Okay. It look like this. And if we see how does that look like, then I will that. So now we have two things, right? So in this column locality and place, I'll use one hot encoding. On property and residential, I'll use ordinal. And as you know that remainder is equal to pass through I have to do so that I'll have rest of the columns, then all the things. Okay, so I'm converting it to pandas also again so that I can look at it. Otherwise I'll have numpy array. So if I don't write this part, I'll have numpy array. So it's a choice, like it's your choice. You want to write it or not. This part. Otherwise you can if you are good with numpys, then you can do it. But I like I have using pandas only all basic to look into the data frame. So now I have the another column. So I go to ct2 dot fit transform. So here I this part, right? Have five. Yeah. So here I'm transforming it, but I'm not storing it in xtrain. Like currently, if you see xtrain, it does have all the null values and all. Like I never changed anything except this question mark. So question marks are now null values, except that all things are there. So this process like of encoding should come after that. I mean, so what we can do is we can store for now and then go ahead. But later on when we'll create the pipeline, then you don't need to store it in any other variable. So uh, so this feature transformed one, I store it in xtrain what imputed. I'm just giving it a new name. And same thing I have to do it for xtest also for now. Fitting should not happen on test. So that's transformation. Okay, so the name was xtrain. Xtrain imputed and byte x test imputed. So that's what I have to use here. Fit transform xtrain imputed. And I have like another CT, right? So it all now have been done. So one hot encoded I applied on locality column. So it will give me few more columns, which I have here. Then I applied on phase one. So I have north, south, west here. Then on property and residential, I applied uh, this ordinal encoder, right? So it will have values from 0 to whatever label, how many
So,
categories are there.
so can I
Yes.
ask a question here?
Yes.
Previously, x underscore train underscore imputed is a variable in which you have stored all the changes, right?
Yes.
Abhi, it will not reflect in the x train data. It is
Yes.
just going, है ना? It is only going to reflect in this variable because you have stored all this thing in this variable.
Yes.
X
Yes.
underscore train will not show any changes
Yes.
unless if I would have written there x underscore train, then it would have reflected in underscore train instead of imputed one.
Yes.
Like if you go up,
Yeah. So
है ना?
I
This is
yes,
what
yes, that is true.
what I was asking. Yeah. कि
So
यहाँ पर
if I write
यहाँ पर
here
हाँ,
this one only, like let's say this,
if you write हाँ, so it
then
will
it will change the extent,
change.
right?
हाँ, then it will change the original x train that we have.
Yes,
Okay.
that it will change it.
Mm.
So to make changes, you need to mention
You
this.
need to
Like you have to
mention,
do,
yes.
yeah,
Yeah,
you have
to
to
do
do this.
it.
So, but currently, why I'm not doing this, because later on we'll create pipeline, then
Mm.
we'll altogether change x train in one go, so that we
Okay.
don't need to,
And also, like this, you have written the list of tuples. Go a little up here.
yeah.
This single family, two family, three family. This we don't need to specify, but you have specified here.
No, this we need to specify since it's a ordinal encoder, and
Hmm.
what I want is from ordinal encoder, I want to have it in some
It
order,
will,
right?
okay, you want in some order. Okay.
Like,
Otherwise, if we are
yeah,
not mentioning, it will not, we don't need to specify. All we can
yes,
do is we can simply write ordinal encoder with
yes,
parents. That's it.
correct. But that
Okay.
will be
The
encoded numerical, yeah,
alphabetically, na? It
alphabetically,
will be
yes,
alphabetically. Okay.
yes.
Okay.
So, if that works for you, then there is no need to mention all these things.
Okay.
Okay, so yeah, so now I have some data like this. Okay, so one date column is there, and like I said yesterday also, that
Excuse me, sir.
date in itself is a data frame. It's a type of data frame. It doesn't come under like categorical or numerical. Okay, so how to handle that is a like time series analysis, we call that. I mean, that we handle them somewhat, but usually like for this kind of data set, like currently what we are protecting is house prices. um, so if your analysis is that, let's say one house is there, how that price across years or across months it got changed. If that is your question, then yes, you can use something from time, uh, or something like that, right? uh, but currently what we are going to do is we don't need that. I mean, for our case, I think the house which is mentioned, it's not repeating again. So I'm not sure. uh, Correct. So that's why we can drop the date column, and then move on. Okay. So I have now. So I have now CT2, and I fit transform it. So I'll store it again in another variable. Let's say x train what encode it. I'm creating all this variable just so I can show it to you. Otherwise, you can of course go with one variable name, and then you one by one, at each step you just change the data frame there only. No need to create new
Sir,
variable.
sir, if we drop this date column, wouldn't the important parameter be removed?
It could be, but uh, for that we need to look into data frame, and like what it is, how much important it is. So let's say I have year column, right? Does the
Mm-hmm.
year itself will signify the importance of this, or do I need to go into months and dates?
Okay,
actually.
okay, okay. With the year, we have at least some part of the time.
Yeah, some part of time we have it. If you want months, we can extract months also. So let's
Okay.
say if you want to extract months, we can do that.
So in
But
general, models are good with the date, time, variable type, or
no, no,
normal input.
date
Okay,
time is not supported. Uh, we need
okay,
to we need to extract the weeks or months or something like that, then put it there.
okay, okay. So it has to be in some continuous variable format.
Yeah, yes, yes, something. So there
Okay,
are few things we do with it. Like one, let's say forget about time series, but without time series, what we do is generally we extract the day out of it. So day means the date on which event happened. We take out
Mhm.
months of that,
Mhm.
month number and year value. Generally, that's what we do, and we keep it here. Another thing is we group things in a categories. So let's say we can say that in a period of like let's say 5 months, 6 months. Okay, so maybe generally it says a quarterly or something. Quarterly is like 3 months. In a period of 3 months, this thing happened something.
Mhm.
So we can say Q1, Q2. That likewise we can create it. Then later on Q1, Q2, Q3 will be transformed to numbers 0, 1, 2, 3. You can do something like that. So limits how much time series analysis you want to do with the data. But yes, it has importance in itself. I'm not saying it's not important. I'm saying that uh, for now we are going to remove it. That's all.
Okay, okay, got it.
Okay, that's so train dot drop. I'm dropping data. These same thing with desktops. Okay, so I have train X test removed with all of them. Now the thing is, let's say if I run this, run test, and then I go to another column transformer. Yeah, it's loaded and encoded. So after imputed, it comes encoded. Okay, test and test again. We did drop here, but you can drop it a little bit.
For test, it is only transform
So
you have done fit
we have
and
applied fit underscore
Oh
transform.
yeah, yeah. That is a mistake. So now, okay. Now the next step is we'll do scaling. So scaling you can do anyone, doesn't matter. So let's do standard scaling. So so I already imported all of the things, okay, from yesterday. So that's why this thing I'm not importing again. So the thing I have to do is paste transform, extend encode it, and this how I'll have. Can again write like that. Pandas. This I have all the columns in extend and encoded, which are standard scaled. Okay, so the mean is being removed from that and then scaled by variance. inverse of h, something. So I have this all values. So this is the final cleaning. Okay, now we are ready to go for a model training. Uh, I have extrain, so I can call this as xtrain. Okay, and there will be another column which is y train, on which I haven't done any kind of preprocessing because it was numerical only, and I don't want to reduce any size of it or anything, right? Though this scale is huge, but I don't want to do it because I want to predict in similar scale only. So I don't want to do it.
But we need to do it on X test, right?
Yes, X train and all, because training data, the X train and all will come into picture of gradient descent. The
Mhm.
gradient descent will happen on that only, on X only features. The Y will be there
Mhm.
to later on. We'll just use it Y for this loss function.
Mhm. Okay, my question was we need to do this transformation on X test.
Mhm. Yes, we have to do it. So I
Okay.
haven't done it, but yes.
Mhm.
So this all processes were there. Like I used multiple variable names and all. Now I'll show you how to create a pipeline. Okay, this is going to be very easy now since we have gone through all this thing carefully. That I created one column transformer, another column transformer, and then I did scaling. Okay, so this three I did this three steps I went through. So mm,
So this Y test that will come, that will be
yeah,
coming on our this X-trained imputed data frame, right? So the scale of Y10 will be totally different from the Y test. The scale,
no,
because we have done scaling
no. On Y
this
test also
value.
on Y we never did anything. On any
Y
Y
test
we
will come, that will be the predicted value based
yes,
on X train X test that we have done, the changes we have done, all the
yes,
pre-processing data and everything. So
yes.
Y test will be different. Will it result into a different scaling because we have changed the column values between 0 to 1?
No, it will not come like that. So see, now what's been happening is, uh, see, uh, I'll show you what's actually happening in this thing. So let's say I had this value 1010. Okay, another value is, let's say, something 2000 and maybe 12 or something like that. Now if you draw it in x and y, okay, let's say along x and y, now same data is there. Just imagine these 2 points are coming very nearer to origin. Okay, but this point are same thing, like uh,
Shifting of the points taking place, na?
yes,
This is what
shifting, you
you're
can
trying to
say it,
say.
or they are coming very near. So
ट्रांसलेशन या कोई भी
yeah,
ट्रांसफॉर्मेशन हो, ट्रांसलेशन हो या कुछ भी
yes,
रोटेशन
yes.
वगैरह कुछ
So
भी
so
है
we
ना.
had like a huge this data frame. Now it shrink very close to zero. Now all the points are very nearer to closer to zero now. That's all. That's what we did till now. Actually, like in imagining
So
geometry wise.
accordingly, Y test will also result into the same, like after the same transformation, Y test will be resulting, no?
Mm, no, we haven't done any transformation on Y. We'll not do anything on like labels. There is some kind
Y,
of transformation, but
hmm,
not here.
Y test result will depend upon X test that we have
No.
already transformed.
Oh yes, yes. So we'll get predictions of this value only, like of this scale. Uh, we'll always get prediction on which we have trained the model. So there is nothing to worry about that.
Okay.
So okay, see, so we have created this three thing. Now we wanted to make a pipeline, right? That is the last part of this. Like put it all together so that we don't need to go through this thing again and again, like for train set, validation set is will going to come, test set will come. Let's say if you do incremental learning, then um, you go through this process hypothetically weekly, monthly, right? So to avoid this all the pain, to process this regularly, we create a pipeline. So let's do that. So from Elan dot pipeline, I'll import pipeline. I mean that's how the naming is going. Okay. The I don't know developer was there who wrote it, so don't blame me. Okay, what it's inside pipeline there is pipeline. Okay. This will take one parameter called steps. Same thing again. I have to do. I have to give tuples and this. So the step will contain array, which will also contain tuple. Same thing, but this time we don't need to choose columns. We don't. We just want to we just want to connect this thing, right? Like connect this to this. That's all we are doing. So I mean that's what I'm doing here. Like what I'll do is I'll say that I just have to name something like let's say uh, column trf uh, 1 or something you can call, and that is ct, and let's say column trf2, which is ct2, right? I'm just connecting, that's all. Then I am doing standard scaling. So SS, like that is the name, right? I use that name here. See, that's why I wrote all these three things together so that you can see that SS is this one, and this is same thing, right? All the thing I wrote there. Okay, so this is how my thing is. I'm just connecting it. So to connect it, I have to give name in the similar order. So here order matters. There it couldn't have because columns doesn't matter. Like wherever column goes, ultimately it represents same data. It's just in the different uh, columns. That's all, right? But represent the same data. But here the order matter. Like the first this will happen, then this will happen. So that's why this the variable name is also step. So this is you can say step 1. This is a step 2, and this is step 3. Okay, so order matters here. I can call this anything, like let's say, I don't know, STP one, anything. You can call anything, whatever feels good to you. So that's how it is. And I need to give a variable name also to this, like pipe or something. Pipe here. Now you can see the picture, right? So all the things are in a pipeline. And the good part is I can do fitting now directly. Like let's say let's do it here. Explain, sorry, pipe dot fit extrain. So see in this you can give y train also, but on y train there won't be any transformation happens. Okay, on y train it will just go along it. So why it is there? Because to this pipeline you can actually add model also. So maybe in step 4 you can add a model, like let's say linear regression or something. You can add it, and then you don't need to worry about anything. Like just do fitting x train y train, and internally it will do all the things. Like so if you do that, then see, if I do fit only, then my data will not change but it will learn all the parameters, all the things across the thing. So whenever the X train goes in, uh, it will do multiplication, all the things, and at last it will build a model out of it. Okay, no need to do transformation of the data, but otherwise you have to transform the data. So see, I did all the things, same thing. So if I show you the part where we did the SS1, this is train X train encoded. The same thing. See, the values are, you see, let's see the head of it maybe. Okay, so if you see both of them, if you compare the same thing, right? The first row I'm comparing now. This, so you see everything is same, right? So nothing. So that's the same thing I did, but now I have this thing. Now let's say I have any kind of data. Let's say I had X, right? Only had X and Y. If I create even four group out of it, any number of X train, X dash, X validation, another axis, I just need to write this part, and fitting will happen, and then I can go and do transformation like ss dot, sorry, not ss, pipe dot transform X test, and that's all. My test will transform. Validation, if I had, I would have done it easily. So that's why that is the good part of this pipeline. So yeah, the next part I was explaining that you can add a model to it. To show you the demo, I can do that. So let's say I wanted to predict with linear regression. So I can do from sklearn dot model for linear regression. And I have to edit here, right? So same thing. It's just inside the pipeline. So I have to use tuple. I have to give a name. Let's say I use linear or something. Okay. And the name of it. Then the so this is how I call this class, right? If I run that, it will have one more point, like after standard scalar, I'm fitting the model. So since I'm fitting the model, the transformation part will not work, because model doesn't transform data. It will just learn from the data. That is the task of model, right? It will never change the data set. The transformers does it. So in that case, I have to do is pipe dot fit L2 X train, comma, Y train, and I have the model. Like, so what I do is pipe dot. The thing I can learn is from like intercept. I can learn things that like that will not work. I have to give uh, the name of it, or let's say if I write pipe 3, that will bring me the linear regression, right? So I can actually go inside this thing. Like let's say if I write pipe 2, it will give me the standard scalar and all. So if I want to access anything inside my pipeline, I can do it with this indexes. So like 0 and all. So the last one is 0, 1, 2, 3, right? So that is my linear regression. And if I wanted to predict the coefficient of it or intercept of that, so I think coefficient is one thing. I have this all coefficient for each column. And same way, pipe 3, which is linear regression, I can print intercept. I learned this. So this much is the intercept, and this all are the weights W1, W2, W3. Not like this is W0. And if I want to do prediction of any value, let's say I had this uh,
There, intercept means the constant.
intercept is no, it's not a constant, right? Uh,
Bias, bias which is added to the linear regression equation.
yes, that would right. So like we have W0, then we have W1 X1 plus W2 X2. So I think except that there is a constant. I mean plus C. Usually we add C, that it's an error term or something. We consider that this
Sir,
W0 is not
sir, could you show me the flowchart of pipeline?
this one or
Sir,
code.
yes, there's a flowchart. So basically, it is first imputing the missing values with mod, then median, then mean, and then it is passing through the value further to
Yeah,
column
so I am
transform.
doing imputation on this two column only, locality and property. The median type of imputation I'm doing on estimated value. Then mean type of imputation I'm doing on carpet area. So this four columns I am doing some imputation. And remainder,
All
the
right,
rest of
sir.
the columns are there, which will be added along after the transformation. So I'll have the whole data frame again. Okay.
All right, sir.
Then see on locality in phase, I needed to do this nominal encoding
One hour and correct.
on one hot encoding, and property and destination I'm doing ordinal encoding, and then again I wanted to add the rest of the features into my data frame. So I have now the whole data frame, I have it, which is uh, imputed, and then I have done encoded also. So now all the columns will be numbers only. There will be no null values present in my data set, and there will be no strings or anything present in my data set. Okay, so except year, I think. Yeah, but year I already removed from my extrain from
Yes, sir.
previously. Like if I wouldn't have, I need to handle it somehow. Okay, I never mentioned what to do with year inside my column transformer or pipeline. Then I'm scaling the whole thing, the whole data frame. I'm scaling it, and I'm applying linear regression on that.
All
Okay.
right, sir. Sir, what was verbose function which was used
Um,
earlier?
okay, so yeah, I'll go there. This one, right?
Verbose feature names are there, sir.
So this will so I'm using this set output function. Okay, set output as pandas. So I'm setting my output as a pandas frame. Otherwise, by default, it's a numpy. So when I do that, it will give me names of the
Columns.
the names I used. Okay, of my transformers. Like this transformers names I use, like one hot encoder. I'm calling that as a nominal encoder. I have to choose the name. Like there is no choice. So I'm doing that, and since I'm doing that, it will show up here. So do I want to be present here or not? I can choose from here. Like it's just a tweak of that one. Do I want this name
Right.
here in my data frame or not? That's
You have set it to false. That is why it is not showing, right?
Yes. If I make it true, then it will show this nominal encoder, and it will all appear,
Along with the original heading.
or along with the original heading. Yes. So let's say if I keep it true, and I'm doing this. So I show you how my explain head looks like. it has nominal encoding, locality, fair field, and all. So this part
Correct.
is getting added in front of it. It's a prefix. It's as a prefix. So I don't want that prefix. So I'm setting it as false. And
Alright,
if I
sir.
do that, then it won't be there.
Alright, sir.
Just for the naming simplicity. Otherwise, it doesn't do anything internally like to the data frame. And
Alright.
yeah, one more thing, you'll come across this another term which is verbose in this, like let's say. So so the what verbose do is will it will explain the things like what you are doing it, or what's happening inside internally. So if you set it to 0, then I think nothing will happen. But if you set it to 1, then it will give you some information, and if you write 2, then it will give you more information. So what is less
Within the
and what is
data frame.
more, that is kind of relative, but it will give you some information. Then if you write it 2, then it will give the whole information it carries.
Within the
Like,
data frame.
no, not of data frame, of the process. So this transformation process is happening, right? So by default, uh, okay, here it is true false, but in grid search CV and all, you will see the 0 1 2 numbering will be there. Okay, so here it's a boolean one. I think I can't make it 2. Yeah, I can actually. So it's a boolean one. I'm not sure. Maybe they forget to change the API, or the introduction or something like that. But see, you are getting the process. What is the 1 of 3? So processing nominal encoding, and it took like 0.0 second and something like that. Processing encoding and remainder like that. If I write 1, then I don't know what will happen in this, but uh, otherwise it will show you less information, like something which is redundant, or without that also you would have understood this part. It will not show that.
So,
So that's so 0 is false, so it will not show. So it depends, like you want this, but generally here we don't want that. We want this thing when we do grid search CV. So later on we'll do grid search CV to hyperparameter tuning, uh, so that our
alright, sir.
best parameters get chosen. Yeah, so this is the column transformer and pipeline. So see, I'm not in many ways you can create actually pipelines. One another way of creating pipeline which people are doing it is, see, I'm using this locality, and then again I'm doing encoding on that. So here I'm going transformers wise, like I'm using and first imputing, then I'm going to encoding and then scaling and all. But some like to do it column wise. So they go column wise, each column wise. So let's say first column was locality. They do all the things in one go. Like they write a pipeline. So first step is impute, then encode it, then scale it, like that. Then in next column they write same thing. So for whichever column which is all the things required, right? They write all the things column wise. Then after that they do scaling all together or something like that. They can do it. Okay. It's your choice how you want to write it. It is one way. The another way is also there. You do it, you go column wise. And another way is you use pandas. You don't use sklearn at all. So it's your choice. Like whichever you feel comfortable, later on you can do it. But I used to do it with pandas earlier with this whole thing. But when I get to realize what is the uh, the power of this pipeline and column transformer, then I completely switch to sklearn. Now I don't do it with pandas unless it is something I wanted, like very different thing I wanted to try out, which is not there in sklearn.
So,
So okay, so that part is covered. Not sure what else is there.
Sir, I have one doubt. Can I ask, sir?
Yes. Yes.
Sir, yeah, this SFS backward and forward, will it give the same result always? Because in lecture it is
No.
showing same result.
Yes, but no. That is not
Sir,
necessary.
excuse me, sir.
Yes.
So it will never.
Could you,
It's not same, sir. Always. It
Yeah,
can be
not.
also.
Yeah, it can be different. Yes, it can
Okay.
be different.
sir, could you share this collab file in the comment section?
Yeah.
Thank you, sir.
Okay. Okay. So somebody had doubt with practice assignment. We can cover that now. Then later on
Yes, sir.
we'll see what we can cover.
All right, sir. Sir, mind if I share my screen?
Okay.
Sir, may I share my screen?
Yeah. Yeah. Sure.
All right, sir. Okay. So, so this is the practice assignment and the data related to it. And this was the collab file I have
Mhm.
made so far to solve the questions. And I wanted to ask that if we are actually comparing the if this question says which of the features has least variance. So if we are comparing the variances of features, shouldn't we standardize those features, right? We should standardize those features, right?
I
Uh,
mean, no. I mean, uh, okay. See, the question is, I mean, we if we do standardization and then compare the variances, then it will give a different kind of result. So when you want to do it is you have to see the question then. I mean,
okay, so
yeah.
all right, so
Uh, if you do it afterwards, then there will be different answer. If you do it before, then there will be different answer. So that here it is asking about the features. I mean, it's not going into the process of the cleaning and all. I think.
yeah, so it's just asking for the value.
Yeah, yeah,
So if
variance.
I
So.
just so if I don't standardize the data and
Mhm,
just calculate the variances,
mhm.
then the answer would be correct.
Yes. So that's what it is required. Like you don't need to change it or anything. It is like just basic mathematics question. Uh,
All right, so
not ML or anything. Cleaning question.
I think that's why I was also getting this answer wrong. Maybe I haven't checked, and so yeah. So which of the following is true about target variables? It has higher yes entries. As per my code, I was getting more yes. Let me show you the data. Basically, this is the data. There are
Mm-hmm.
total 748 entries,
Mm-hmm.
and somewhere I must have looked for yes as well. Let me see. Yeah, all right. Okay, okay, okay. My answer is wrong. As higher no. I don't know why I miscomputed the answer. Uh, yeah,
Okay,
and
so okay,
there
you're
is
saying so. I mean,
uh,
is
uh,
it
so
wrongly computed or wrong answer given? Which one?
No, the answer is correct, but I think I misconcluded the answer, misconcluded the results,
Okay.
maybe due to lack of attention. And
Okay.
yeah, and this is what is the average of first column after applying KNN imputer? I
Okay.
was
Is it there?
getting none of these, and here is the code. So
So
I had I so here is the code for this. KNN imputer X7 dot drop V5. I have dropped V5, which is actually a categorical variable, negative and positive. It contains all the negative values.
Mhm.
I mean, it contains all the string uh, that is negative. And so, and I have fit the data X underscore 7 here, which is,
Okay. So,
yeah,
so you
and
just
in
need to
X,
apply KNN on first column. That's all, right?
yes, sir. And I have replaced question marks with the
Uh,
null values. Yeah. So after I have applied KNN imputer, and then I calculated the mean for V1, the first column, which is coming out to be 9.532, 9.533 almost.
okay.
And there is actually no option for 9.533 here.
Five. Okay. Average of
The correct
first.
answer is 9.562.
KNN imputer with n neighbor equal to 3.
Yes, sir. I have
Okay.
used that neighbor equal to 3 here.
N neighbor 3 and uh, X7 drop column V. Okay. Can you show me the first column? Can you print the first column
Okay, sir.
before doing any change on that?
Before doing of the original data.
Yeah, or something. Yeah, on that we have to apply, right? On original data.
Uh, okay, sir. Yeah. Let me show
So
you.
which contains question marks and 0, 1, 2 or something like that.
Sir, do you want to see the first 5 values or more? Here's the first one.
I can. Yeah, okay. And
I have replaced the question marks with the null values
okay.
before applying the analytic.
So applied, removed. Okay. Okay, what is the average of after applying? So average of first column.
So, you asked something for me.
Sorry.
See, did you ask something?
No, no. I was just looking by your answer as different answer coming for you. So you remove the last one and then you apply KNN imputer and So this is coming out to be little off. I'm not sure now. Maybe what we can do is we can try doing that. Then get
Sir, for KNN imputer, weight should be uniform like that. One more parameter is there. Maybe that thing is changing.
I think that is default.
Slides one explain.
Yeah, I'm not sure. Okay, I need to let's try for now. If we'll get the result, then it is. Otherwise, I need to look into it again. So let's say from sklearn dot use simple, but and say enable equal to page. Need to here. I'll put the data. So let's say my PJ data is pd dot csv. What has that here? I have this data, and on that they are saying but the problem will be that even though I remove target, v5 is kind of numeric. It's not numerical, so that is also a case. Drop. Let me drop v5 and target for now. So that is v5, and I guess target. We need to here. Okay, I am fitting and transforming it. V5 and target not found in access. PA data.
So the quotation have issues. The quotations would be separate. For v5, it should open and close. For target, it should open and close.
No, this is yeah. So this is working. Use this. This is my transform. This is my data, and Okay, there is a question mark. To make a change in that, I have to like a dot replace a v1 dot replace by right uh, question mark with np dot. Then I'll just keep in place to this. See that there. I am replacing that, dropping here. Uh, remove to V. Is it there in another column as well? Okay, it's there in V2. It's there in V2. I think I have to remove from everywhere. Dot replace. Yeah, I get replace from all of them. Now I have this. L E B. What I can do it. This. And let's say this is ENN. So dot mean, right? 9.53. What is coming out for you? 9.53.
Yes, sir. It's 9.53.
And there is no one which is nearer to 53. Okay. Average of first column after imputation. So we had this P5, right? I mean, I am not sure how this is being computed otherwise. Like, let's say if I see VA, and I
Sir,
see
in this
V,
KNN imputer, there is one more parameter, weights, no? Because for weights uniform and weights distance, it is computed differently, right? So
yes, yes,
that
that is true. So it is only one variable, so it doesn't even make any difference even though if we do. So there is another parameter, yes, like this weights, right? So we can, so there is uniform and
weights equal
another.
to uniform, weights equal to distance. Something like that. Yeah,
So
distance.
let's say even though if I use distance, well, no, it doesn't
The
null
options
well.
are incorrect.
Like this. Yeah. So this is KNN neighbor 3 distance. I don't know why it's not coming out to be.
So what is the issue in this question? I just got disconnected. The
Yeah,
answer is
so
not coming right.
yes, for him it's not coming out to be right.
Oh, okay. I have just like for me it's coming right, sir. I have put the code in the chat box.
Yes, it came for me as well. I also put
It's
put my
correct.
code above. Yeah, the answer is
It's
correct.
very
Yeah.
simple. It's very simple.
So oh, okay. I think
So,
if you
so
do
if
it
we
for
force feed the column, if we force feed the column to
yeah,
the transform, then it works.
I kind of got it. So see, the thing you are doing is you are doing it on one column only,
One
the
column
fitting.
only. Yes. Yes.
But then it defeats the purpose of K and input actually. But okay. So I think the question
The question asked only for the first column.
true, but yeah,
So how would it defeat the purpose? Like we are trying to find that missing value on that column, right?
mhm.
We are
I mean,
trying
yeah,
to
I got
find.
your point. So see, the question is incorrect. I mean, the it's true. If you do it for one column and let's say you got the answer, uh, you got the right answer, but the question is incorrect then because the KNN imputer we use it so that we can find the points which are nearer to the missing one. Okay, so there is a missing point uh, which does exist in other another columns. It exists, but for that column it is not existing.
So
So it kind of
actually, after applying KNN imputer means it imputes for all the columns, and then you find the average of the first column, right?
yes, that's how you do it
Yeah.
in
But
reality.
this
But
particular code last May whatever you pasted, it is only for V1, is it?
yeah, so it's an
Okay.
incorrect question then. I
It's
mean,
an incorrect because KNN consider all the features and then it finds the nearest. That's why.
like
Okay.
that is the purpose of KNN imputer.
Okay.
So
So that
if you're just giving one column, how does it calculate? Like
then
I
it
don't know.
does from that only, like that one dimension. It is not taking another dimensions and into the picture, ignoring them.
so it's is it like minimum three distance only calculating it, just the three closest distances,
Yeah, three nearest
three
people.
values that's closest to it.
It's calculating only for that component, like for
Yeah,
the first
yeah.
feature, V1.
Okay, I'll explain that. Yeah.
Then also in one of the videos, if I recall, values are like NaN, so it
Mhm.
doesn't consider that component. In one of the lectures, I think
Yes,
Professor, no? Huh.
it yeah, that is true. That is true.
So that's why
Uh,
it's working.
yeah, it does it computes non-Euclidean. That's why I think so. There's one thing called non-Euclidean distance in this. So in this distance will be required to compute the nearest neighbors, right? So for that purpose, for finding the distance between 2 points, let's say I have like in school or somewhere you have used like x1 x2 or x or y or something like that, it's there. Let me use x1 y1 1 and y1, then I have x2 and y2. So we used to compute like x2 minus x1 whole square plus y2 minus y1 whole square to the under root. So something like this is a distance formula. uh, but here what's happening is we have these 2 points. We have x1, but let's say y1 is not there for this point. In this case, it's x2 is there, but y2 is there or not, that doesn't matter. Okay. So now we wanted to compute the distance between these 2 points. Like the problem is this. I mean, a few columns doesn't have any values, right? They are null or null. So how to do that? So in this case, what we say is wherever value is present, compute from that distance. So here x1, x2 is present. So what we do is x1 minus x2 whole square and under root. So let's say if a point is in 4D, okay. So to write a 4D, I'll use x1, x2, x3, and x4. Okay. So this is one point in a 4 dimension, like, and then another point is there. I can use y for naming them, but let me use something else.
So there's a component of weight as well, which
Yeah.
varies from point to point, depending
Uh,
upon the number of features available for the data point.
yes, there is one another point also. Yeah, correct. So if I use weight, if it's not uniform, or yeah, it does multiply by like total.
Scales to the total features. But
Yeah, something like that.
sorry, in this case, if you are just taking one
1 by
column,
2 or something. Yeah.
Depends on the number of features that's available. It multiplies by that.
Yeah. So number of feature available and total feature available. It multiplies by that. So it's like 1 by 2. You will multiply by that. And yeah, that point I missed. But
So in this case, if you are just taking one column, we have to calculate a distance, right? So
yes.
if the value is missing, how will we calculate the distance? Like
So
if
it
there is
will.
multiple features, like we can do all this, right? We can
Yes.
there
So
will be one distance available. We can add weight and calculate. But if it's just one column, that's the computer considering. How will this distance get calculated?
Yes. So okay, I even see. I'll show you the output. It is 0. It's not giving you the result. Can you see this wasn't 0 earlier? You see, think, yeah, PK data.
So if you are share,
Yeah,
it's not showing. So are you showing?
Yeah, I'm not showing that one, right? I am on different one. I think it is coming out to be 0. Five and 3, 1. Okay. On 1, how it is doing? No, it's not coming out to be 0.
Are they taking like the 3 lowest values in the column and taking mean of 3?
Then, but it's still changing and all. It is, if it's a null value and you put on one parameter, okay, and then you compute it.
Sir?
Yes.
One more thing in that code, why did you drop that V5? Was it because it was a target variable?
No, I did that because V5 was not target. It wasn't numerical data. It was categorical data.
So
So
you can encode that. So maybe at that time we may get the correct mean. We are leaving that entire column.
you can do that. You can encode and do it, but to be if I say to you,
a single column B1, it's wrong. No? We have to consider wrong. We are getting mean wrong means we are leaving that column, B5 column. We should encode and do the thing. Maybe we get.
But in this, let's say in this case, it is negative only. Like all the points has similar thing. Okay, one value. So even if you do it, I don't think so there is any difference it will make.
But
Even though if you
generally,
do
sir,
it,
what is the method? Do we consider the categorical column also for imputing purpose? Like we encode it and
okay,
then
which is the correct way? The correct way is debate. I see if I have this 2D, and there are few points on 0, and that's a 0 is there, 1 is there, and like this. And on the other one, it has like numerical column, so it can contain any value like it's a 10, 20, 30 or something. So this is let's say around this point could be 5. This, and then I'm computing distance of this. Yeah, you can do it. You can encode and do it. So you can do encoding and then compute the distance. Um, that is much better. If I don't have that, then along one axis I won't have the distance of that. So so it will be like you are removing one kind of
So,
dimension
so
from
in
the.
case of just one column,
Uh,
this is what I got from ChatGPT. It says if it's just one column, it takes just the nearest indices. Like if you put 3, then it takes nearby 3 indices.
Okay, so it will take 2, 4,
Yeah,
and which one?
like if there is like
5,
if
2,
it's
4.
3 and n equal to 2, it will take 2 and like 5. Like if it's 4 and we in the missing value is at 4 and n equal to 2, then
Okay,
it will take
let's say I have this data. Uh, let's stop sharing here, and I'll go back to my this thing. Let's see again then. It will take, if it takes the index, then so for third or second one, if I say I want only zeroth. No, I want a few many rows, but zeroth column. So I'll write like from again like 2 to maybe let's say 6. See what values we are getting. Yeah, 2 to 6. Okay, so first, let's say for third one, if I want to compute, that is like one null value, 4 and 1. And for third one, it's coming out to 3.7. 1, 2, maybe 7 or 8. The first 8 points. So let's say for third one I want to impute, then the nearest one is 2, which is kind of useless to us for now. If I do it for 1, 4, and 2, still I will get x 6 and 7. 7 divided by 3 would be 2.33. That is also not there. So how did second one got imputed? Second one, let's say 1, if I take the nearest one, still 4, 2, 1. I'm not getting. Oh, okay. I think we did it. We didn't do it this way though, right? So that's right. Yeah, let's do it this way. Then only I think of that. No? So if it's the question, but None of the index we can.
So there's one more data you've not replaced. TA
Square bracket is missing.
Here
Yeah,
transform.
here I have to do it.
And last May one extra square.
That is. Yeah, okay, so I have this now. Okay, so second one I'm getting is 9. Third is also same thing. Okay, I think we are replacing everything with 9.56 only. One more thing I require. Wait. Let's say I have this one. I am replacing question mark with null values, and I am not storing in there. Let's say I call it maybe ABC or something. And C, ABC. Okay, somewhere here I have imputed all these things. So yeah, I think all of them got imputed with same value, all the question marks, right? That's what it looks to me. Data dot is dot is for this this 5, 2, 3, 7, and 11, 16. So yeah, I think that's all only I have 2, 3, 7, 11, and 16. These 3, 5 points. Yeah, they all got imputed with same value, 9.56, which is what could be that? I think it just took the mean of that column. Yeah, I have. If we take a mean of it, can only concurrent string, not integer. To okay. Yeah, that is the mean of the column. Without even though I don't do anything, like the mean is getting imputed. It's like it's like you can say a simple imputer with mean. Yeah, that's what's happening here. 25841 2. Yeah, I mean that is the last one. Same thing. Okay. But this question is incorrect. Okay, we need to change it.
We can change the answer.
No, the question itself is incorrect. So I mean, it doesn't make sense. See, what I mean,
if you can add 5.3 as answer, then it becomes right, right?
9.53. Then, but then we need to mention that the use. I mean, in this case, we need to mention that encode the last column, then do this. We have to mention that. So changing the question bit is required. And then fit Okay, then you can fit all the things and then compute the distance. So that's how
So,
it
but
should
now
be.
you did not encode the last column, right?
Now we didn't do anything. No, we just took last
You,
like for one column only.
hmm.
So
No, when you got the 9.533 also, you dropped that column and you just did for the other rest of the
yeah,
columns.
because it was not mentioned in the question, so I thought maybe try it out. Let's
Hmm.
see. I was just trying it out.
So that way, as Sharad said, you can just change the answer to 9, also include 9.533, so that no, usually generally they do encoding and then compute the KNN?
Yes, yes. Do encoding and then compute gain.
Okay.
Yes. And you can use only KNN if you want to impute any numerical column. So in categorical column, KNN will not work.
So then it makes sense to drop that column, right? For this KNN imputing.
No, it doesn't. Why it's not making sense is because let's say if it's a one hot encoder, like one hot zero, it contains only zeros and one. Then
Because, sir,
probably
in the pipeline flow also you had given first impute, then encode, then it is our wish, is it? That it's not necessary that it
uh,
has to follow that.
yeah,
What
yeah.
does?
So the problem you will face doing this is if there is a column which contains so if there is a categorical column which contains null values, then you have to first impute that part, that categorical part, uh,
So in that case,
and
we need to do encoding first and then impute.
yeah. So yeah, the way we did it, you can change the orders.
Okay.
It's not necessary that you do it in this order only. You can change the orders.
Okay.
Orders have no no like
There's no restriction.
straightforward. There's no restriction. You
Okay.
can interchange them.
Okay.
But scaling will come last. Like you can't have anything with that. Scaling will always be last. Still, the scan in imputer is it's like a just little bit. I haven't seen people using it. Though this is a good.
Is there like a guideline like when to use which one, like depending
No, no.
on what kind of data or something?
There is no such guideline since this the central tendency, right? This mean median mode we call central tendency of our data. So which one will represent better? That's what we wanted to put in a null value place. That okay, this will represent better my data. So that's why I'm putting it here. That's how it goes. But in KNN, what we are trying to do is we are saying that okay, let's say I am the person who doesn't know which central tendency would be a better one. So what I'm doing is I'm finding which are nearest neighbor to me, and okay, what kind of value they have. Let me take average of that. So that's how it goes. But let's say if it is a categorical data, then that will also fail there. Mm, so I mean, see, the imputation is kind of tricky, and like I said, in reality, we should encode first and then do imputation. Let's say don't encode and then do imputation. Still, it works. Why is that? Is like the change in answer you will have is very minute, really very minute, and I mean it works. Like you are imputing values instead of null values, you are giving some value, right? So some change you can accept it. So but how much change you can accept it is what we do after imputation is we look into the graph of the data set. Like let's say xtrain before the imputation, like not extent, but the column before the imputation, and column after the imputation, the histogram. All the numericals for the numericals, the histogram is there. I mean, in categorical, it doesn't matter, I think. But for numerical, we see the histogram. If histogram is changing too much, like it is, let's say it was earlier right skewed, or if you know the skewness, like right skewed and all, it became totally normal, or it became left skewed, or something like that. You can see that there is a huge change in the graph. Then you know that this whatever imputation you did, it's the wrong one. The data set, column, graph should not change. Distribution should not change. That's how it works. So after imputation, you can figure it out. Is it a good one or a bad one?
So why I asked about the guideline is like I was reading through some stack forums and all. Like someone was saying like if data is collected from different places and all, and sometimes there is similarity between the data collected in one place, so the rows will be similar. So in those cases, KNN will be suitable one or something. So I was asking like, is there some general?
Rows were similar. No, then I am not sure about that. I mean, that in-depth thing, I don't know. But generally, I like the central thing. I have idea, like what is the central tendency and all. Let's say even though if you use KNN and all, still you can see the same thing, like picture, plot the graph, histogram and all, numerical data for columns, plot the histogram. After imputation, look at the graph again. Okay, before imputation, like remove the null values, keep them aside and plot it, and you put this null values inside, like with a replaced one, then plot it again. So is there any difference in the graph? If it is too much, then whatever method you use, it's a wrong one. KNN or simple impure or any other thing. Distribution should not change, not be changed.
Same idea as when we use the stratified, like we shouldn't change the data collected. We just like.
Yeah, you can say that. So we should not change the. So what happens in that is like generally we use stratified on Y, like labels, and that comes under like classification type of problem. So sometimes we have some classes like labels, which are representing very minority in the data set, and we don't want them to lose at all. Like we want them to have some portion in it, right? So that's why we use stratified in that case. Otherwise, there is a possibility that if there are minority labels are there, we might totally lose them or miss out them in training set. So to avoid that to happen, we use stratified. So I think for today we'll keep to this only. Still, this feature selection is pending. I think we have to do it sometime. So that one part is pending. Feature selection. PCS is there, but PCA wise we don't have to do much. So chaining transformers we did, that is pipeline. Heterogeneous feature transformer. Categorical transformer, which is this filter. So this feature selection is pending. Okay, which we have to do it.
Actually, week 3 has got a lot of things to remember.
Yeah. So
Loaded with
you, to be frankly, if I tell you that the whole in this whole course MLP, only week 3 is the one which is important. I mean, you will see that in ML, your ML life, you will come across this only always, and not other weeks. So
So
yeah,
more we
it is
practice, it is better.
Yeah, so week 3 is the one which has all the things, if you learn the week 3 one, and let's say you couldn't able to figure out rest of the week, that's fine for me, I guess. Yeah. I will be still happy for what you learned.
Okay.
Yeah, so go through
We
it.
can
Okay,
focus
so
on the pipeline, right? Like, do we have like? I mean, like, if you want to remember the format, should we just focus on pipeline?
no, just not absurd, just pipeline. Like there is encoders, then this imputers, scalars.
Yeah, I mean that will come inside the pipeline, right? I mean, like,
Yeah,
so.
that will come in pipeline. Okay, yeah, then yes. So one point we didn't do in pipeline is so for now we created the pipeline without any feature selection part, right? Or dimensionality reduction. We didn't do it. We fitted the model before that. So like this. So after scaling, you can do feature selection or PCA. Any of them will work. So feature selection is a part in which we select the columns, which column to go into the model. And in PCA, we reduce it from n dimension to any number, right? 2, 3, 4. Any number will is possible. So any way we do it, then we fit the model. So one component missing from in this I can say that is PCA or feature selection. So that also you can add it to this. Then your pipeline is complete. Yeah. Okay. Okay. So I think that's that for today. We'll meet on Thursday.
Thank you, sir.
Thank you, sir.
Thank
Thank you very much.
Thank you, sir.
Sure. Thank you.
Thank you, sir.
Thank you.
Stop streaming.